And now recording. Right. So we're down to just one last section for the test, which will not be this week, still be next week. So 4.8, something called Newton's method of approximation. There's one formula there. You want to put that in your cheat sheet, of course. Okay. Reminder, Thursday is a flex day. There are no classes at all for CSM. Teachers have to meet and so forth. Okay. And we do meet Friday, so we're swapping these two Fridays. Quiz on Friday. The quiz will more than likely be an applied max-min problem, a word problem. Okay. And the exam is going to be on Friday the 30th. Okay. Again, I will try to keep the rest of the schedule somewhat as is. So even though you won't be tested on it on the 30th, I will go on with 4.9, 5.1, and so on. Okay. To be honest with you, I think the best day for me to give you the test would have been Monday, but I'm not sure you wanted to take a test on Monday, and I'm not sure I want to grade exams on Monday. It's always nicer for me to have the weekend to grade your exams. So because of that, I'm going to be doing it in this fashion. Okay. Right. So there we go. So let's get started with our last section for the upcoming exam, 4.8. So it's called Newton's method of approximation. A little bit of theory. Some equations are either too difficult or actually impossible to solve for x. Equation 1 is such an equation. 48x, 1 plus x to the 60th minus 1 plus x to the 60th plus 1 equals 0. Okay. It's very, very difficult to solve such an equation. I've mentioned before, quite often when you have an equation that mixes up polynomials and trig, or polynomial and exponential, there's no easy way to solve for it. So all we're going to do is just an approximation. Okay. Of course, if you have a graphing calculator, which I'm not expecting you to have, you can get a graphing calculator approximation. But what if you don't have a graphing calculator, or what does a graphing calculator itself do? Okay, so a little bit of background theory on what's going on, and then I'll just tell you what you need for the test and so on. Okay, and by the way, I just got a message, my internet connection is unstable. So if I disconnect, just don't leave. I'll try to connect back within, 5 minutes. That's happened before, as you know. All right, so here's a function in blue, f of x. We're trying to find where does it touch the x-axis. Okay, and there's no easy way to solve for such an equation. All right, so the first thing you can do is guess, right? Now, if you guess, you're probably going to guess wrong, right? If I just make up a random equation, blah, 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 equals 0, and say, guess a number, you're probably wrong. Okay. So here it is. See this x1 here? That's your first guess. It's probably wrong. So if it's wrong, let's pretend it's positive. It could also be negative. x1, f of x1. Okay. Now, what they're saying now is, suppose I draw the tangent to the curve, the red line, and it'll hit here at x2. That would be my next guess, and then just repeat the process. Do the same thing. So x2 is probably wrong, but do the same thing. Okay, it's iterative. It's an iteration. I-T-E-R-A-T-I-O-N. You don't have to write that down if you don't want to, but some of you know what I'm talking about. And especially you computer science people, this is a good problem in computer science. In fact, there's a way to write a program. Okay, you computer science people, you can write a program that does or approximates Newton's approximation. Okay, but now on the next page, figure 3, page 346, here's the concept. Same picture. Sorry, it's a little bit blurry, but I need to put it down so I can show you what's happening. Here's our first guess. Probably wrong. Draw the tangent to the curve, comes down and touches the x-axis. That's my second guess. Come up to the curve. It's probably wrong. Come straight down. I get another guess. Repeat the process, draw the tangent to the curve. Okay, so notice by continuing that process, you get closer and closer and closer to the root. So see x1, x2, x3, x4, right? So the process is x1, go up to the graph, draw the tangent line. That furthest to the right red line, come down, touches x2. It's probably wrong. Do it again, go up to the curve, draw the next tangent line. The second from the right red line gives you x3. Go up again, do the same process, then you get x4. In this particular instance, by the time you get to x4, you're very close to the root. Okay, so it's an iterative process. You repeat the same thing over and over and over again. Again, you computer science people know how to do that. It's recursive. It's a recursive call for you computer science people. If you have no idea what I'm talking about, don't worry about it for now, but some of you may know what I'm talking about there. Okay, so you can do the math for this. I won't bother to show it to you, but you can figure out what the next computation is. Okay, you have x1, you have f of x1. This means slope. Okay, here's a point, right? So you can find where this is. Here, the y coordinate is 0. It's x2 comma 0. You can do your y2 minus y1 divided by x2 minus x1 and so on. Okay, I'll just tell you what the result comes out to be. Right? So that's the process of what's going on in theory. Okay, make a guess. It's probably wrong. Tangent line. Then start over. Take that guess, tangent line. Take that guess, tangent line, and you get closer and closer and closer to the solution. Okay, and here's the final result. So page 346, box 2. Put this thing on your cheat sheet. X sub n plus 1 equals x sub n minus f of xn divided by f prime of xn. Okay, and sorry, this book is too heavy. I have to lay it down, but for those of you that want to actually write it down, you can look at the video later. But for those of you with the text, it's on page 346, box 2. I'm putting it down now because the book is heavy. But x sub n plus 1 equals x sub n minus f of xn divided by f prime of xn. And you keep doing that. You keep doing that until you get closer and closer and closer to the true solution. Now, I have the Melvin-Hom variation of that, which is exactly the same. And this is what I like. Okay. If I were to make you memorize it, which I'm not, okay, this is essentially what's happening. X new is the x old minus function divided by derivative, f divided by f prime. Okay, this is equivalent to this. X sub n plus 1 equals x sub n minus f of xn divided by f prime of xn. Okay. In practicality, you have a first guess. Either they will give it to you in some of the homework problems, or you have to make up your own first guess, minus function divided by derivative. Okay. The whole idea is to find out when the graph touches the x-axis, i.e. when f of x is equal to 0. Okay. Now you might say, well, how do you know when you're finally done? Okay. Well, you're finally done when x sub n plus 1 and x sub n agree. Okay. This is what I call x new and x old. And let me show you quickly what that means. If you get to the point where these two are the same, the new number is the same as the old number, you know you're finished. How come? Okay, pretend these two are equal, right? That means whatever's behind my fingers minus some fraction has to be 0. And when is a fraction equal to 0? Top is 0. And that's what we're looking for, the function value to be 0, f of x equals 0. Okay, so in doing this process, when you get these two to agree, you're done. Okay, because that means this fraction is 0. That means the top is 0, and that's what you're looking for. You want f of x to be equal to 0. All right, so you'll be repeating this process over and over and over again, essentially. Okay, put it on your cheat sheet. Again, the last time I taught this class, meeting face-to-face, my class had to memorize it. So, you know, you should be happy about that, I guess. Okay, so x new is x old minus function divided by derivative. It's the same thing as this. X sub n plus 1 equals x sub n minus f of xn divided by f prime of xn. Okay, now, you don't have to draw any of these pictures. In case you're wondering, I have no idea what you're talking about, those tangent lines and all that stuff. Okay, that was all theoretical. I'm supposed to show you that. Okay, some of you might have liked it. Some of you followed along. Some of you say, I have no idea what you're talking about. My head's spinning. That's okay. What do I need to do for the test, right? It's the formula at the bottom that I had just showed you. Whoops. Actually, this one is better. Just be able to use this, which is the same thing as my version. Here, x new is x owed minus function divided by derivative, f divided by f prime. All right, this is very calculator dependent, so get your calculators ready. And we'll start doing some of these. Okay. So we're up to 4.8, and we have 6, 7, 8, 11 to 16 all. Okay, and as usual, I'll do as many evens as possible, maybe sneaking some odds, and that's it. So again, to do the 70% homework requirement really is not that hard, considering I end up sometimes doing 70%, maybe even more, but if not, minimum is what, 1/3 of the problems, 30, 33%, 40%, in which case the actual problems you have to study on your own or work out on your own are much less than 70%, right? Okay, so how do you do the work? So 6, 7, 8, 11 to 16. Let me show them to you. So there's 6 at the bottom there. And what page am I? 348. There's 7 and 8 on page 349. And then 11 through 16, 11, 12, 13, 14, 15, 16. And there we go. Okay. So yeah, let's look at the directions. Bottom number 6, use Newton's method with the specified initial approximation x1 to find x3, the third approximation to the root of the given equation. Give your answer to 4 decimal places. Okay, so 2x cubed minus 3x squared plus 2 equals 0. x1 equals -1. Okay, so what do you do? All right, so this is very calculator dependent. And to save time, I've actually done all these calculations ahead of time. You go back and check them later after class to make sure all the calculations work out for yourself. But most of the class time I don't want to spend on punching in a calculator. All right, 2x cubed minus 3x squared plus 2 equals 0. x1 equals -1. That means that's your first guess. Your first guess is -1. Okay, and off to the side I say you always want the function to equal 0. If it's not equal to 0, you make it 0 by just subtracting. Okay, so let's pretend this side had equals 7. Well, just subtract 7 and then you got it. Suppose the right hand side said sine of x, then just subtract sine of x, and then again you get 0. So it's always got to have a 0 on the right hand side. All right, so the function given is this, 2x cubed minus 3x squared plus 2. And then of course I need its derivative. So f prime of x is 6x squared minus 6x, right? All right, now I mentioned earlier about a shortcut using the answer button. Right now, I'm going to pretend you don't have the answer button, which means everybody can do what I'm doing right now. And then later on, I'll show those of you that have the answer button the shortcut, which will make things a little bit easier for you folks. All right, so here we go. x2 by formula is x1 minus function divided by derivative, f divided by f prime. So x1 is my first guess, -1. Minus, all right, then it goes function divided by derivative. Okay, the x new is the x owed minus function divided by derivative. Okay, so I plug into the function, 2x cubed minus 3x squared plus 2. Plug in -1. -1 goes there, -1 goes there, -1 goes there. Okay, -1 cubed is -1. -1 squared is 1 plus 2. And then in the bottom, I put f prime. Okay, so -1, -1 squared is 1, 6 times 1, minus 6 times -1. Okay, so put -1 for the function on top, put -1 for the derivative on the bottom. Okay, you work all this mess out. Let's see, that is -2 minus 3 plus 2, so that's -3. The bottom is 6 minus a minus 6, that's 6 plus 6, 12. -1 minus a -3/12, that's -1 plus 1/4, or -3/4, which I'm going to say is -0.75. Okay, so that's my x2. All right, so in the directions, they say go out to x3, and then you can stop. Okay, as you can see, the calculations can sometimes get really tedious. Right, it's iterative, meaning you keep doing the same thing, or it's recursive. For you computer science people, you know, it's a recursive process. Just keep calling the same function over and over and over again. All right, so use the same thing. X3 is x2 minus function divided by derivative. So my first guess was -1. Then by doing this process, my next guess was -0.75. Okay, now -0.75 gets plugged in everywhere, right? So it gets plugged in to the function on top and the derivative on the bottom. So -0.75 minus 2x cubed, so 2 times -0.75 cubed minus 3 times -0.75 squared plus 2 divided by 6 times -0.75 squared minus 6 times -0.75. Okay, and maybe, you know, I don't want to leave you completely out of the code in case you're not sure how this works out. So I'll actually type this one out on my calculator, but this is what it's supposed to come out to be. Okay, so let me try this. 2 times blah, 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 blah. Okay, so 2 times -0.75 cubed minus 3 times -0.75 squared is the same as 0.75 squared plus 2. Okay, so the top is -0.53125. Okay, in case you're wondering, I left off the negative here because I know -0.75 squared is the same as +0.75 squared, so you get away with that. So it's negative, but I'm going to have a negative here and a negative here, so it's a double negative. That's why I changed it to a positive there. Okay, then the bottom, 6 times -0.75 squared. So 6 times, I'm just going to say 0.75 squared. And then minus 6 times -0.75, 7.875. Okay, so again, yes, technically I'm supposed to put a negative here, but -0.75 squared is the same as +0.75 squared. Save yourself some energy there. 7.875. Okay, and then that's a double negative. So finally, x3 is all this. And let me actually try to show you that. Yes, I applied a double negative over here. So -0.75 plus 0.53125 divided by 7.875. Okay, so -0.75 plus 0.53125 divided by 7.875, and -0.68253 to 4 decimal places is -0.6825. Okay, so our approximation for the solution right now is, for this thing, right, is -0.6825. If you want to get even closer to the answer, do it again and again and again until you start converging, is the language we say, until you start getting closer and closer to the true value. Okay. All right, so let me show you this from start to finish again. So do the focus thing. Okay, so my first guess was -1. Use the recursive formula. Where does this come from? It comes from doing the actual math on that technique. Figure 3. You make a guess, draw the tangent line, make a guess, draw the tangent line. You don't actually have to draw it. Okay, you can work it all out, and it comes out to be that formula. Okay, so no graphs needed for these. Okay, so on top, plug in -1 for the function. On the bottom, plug in -1 for the derivative. So my variation, x new is x old minus function divided by derivative. Okay, so grind that all out. Came out to be negative 0.75. And then do it again. So plug it all in, grind it all out. Okay, and negative 0.6825 is what we get for this one. All right. Okay, moving right along. Let me see, number 7. 2 over x minus x squared plus 1 equals 0. x1 equals 2. So your first guess is 2. All right, so in order for me to take the derivative, let me rewrite this as 2x and negative 1 minus x squared plus 1. All right, f prime, what's the derivative of this? Negative 2x and negative 2 minus 2x. Then rewrite it better for algebra as negative 2 over x squared minus 2x. All right, now I start the iteration process. Okay. So they tell me to go out to x3 only. So that's probably all we want to do. So x2 is x1 minus function divided by derivative, which is the exact same thing as what I have. The new x is the old x minus function of the old of the x owed divided by the derivative at x owed. Okay, so they told me to guess 2. So in the function, so x2 is x1, 2 minus. Okay, now I plug in 2 to the original function. 2 goes there, 2 goes there. 2 over 2 minus 2 squared plus 1. Okay, it's pretty clumsy, but yeah, it's doable. Then I plug in 2 to the derivative. Put a 2 right there. Negative 2 over 2 squared minus 2 times 2. So that becomes, I should put an equal here, I suppose. 2 minus 1 minus 4 plus 1. 1 minus 4 plus 1. On the bottom, you have negative 2 over 4 was negative a half minus 4. So clean it up. 2 minus 1 minus 4 plus 1 is negative 2 divided by negative 4.5 or negative 9 halves. These two negatives cancel. And so I'll have 2 minus 2 times, this comes out to be 2/9. And looks like I messed up here. I got a negative there when I shouldn't have had a negative. I stuck in a negative for some reason. Okay, I totally botched that up. So it's, okay, I have to cross this out, sorry. So it's 2 minus 4/9. Two minus 4/9, which is 14 over 9. Okay, so that's my x2. All right, then I take that 14/9 and plug it back in. Okay, so what I have here is not going to work. I totally botched this up, sorry. Okay, so that 14/9 goes back in here. Okay, so I have to show you how clumsy that is. So let me write that separately here. X2 equals 14 over 9. So x3 is x2 minus f of x2 divided by f prime of x2. it's 14 over 9 minus function divided by the derivative. Okay. So 14 over 9, that clumsy thing, goes in here for the function and also here for the derivative. Okay, it's a big mess. All right, so here we go. 2 divided by 14/9 minus 14/9 squared plus 1. Okay, so that's the function. And then I throw it into the derivative. Negative 2 over 14/9 squared minus 2 times 14 over 9. Okay. All right, let me actually type that out now. So yeah, this one, since I botched it up before, I will have to figure that out. Okay, so I'm plugging in 14 over 9. I'm going to store that in my answer. All right, so I'm trying to type all that out. So minus parentheses 2 divided by minus answer squared plus 1 divided by parentheses negative 2 divided by answer squared minus 2 times the answer. .5215. Now, as you can see, it's very easy to mess up here. So I already messed up. So if you have this algorithm okay, and you get the wrong answer, but your process is good, I'll give you partial credit, of course, because it's very easy to botch this up. I've already botched it up once. So let me just check that I typed it in right. 2 divided by answer minus answer squared plus 1. Negative 2 divided by answer squared minus 2 times answer. Yeah, I think I got it. Okay, so let me go back and do the focus thing on that. That up to there. And then the continuation is here. Okay. Okay, then next one I want to show you is number 8. X to the 7th plus 4 equals 0. X1 equals -1. Okay. Essentially, we're finding the 7th root of -4. If you stop and think about it, and I'll show you that. Okay, x to the 7th plus 4 equals 0. X1 is -1. Okay, this is just a side note, what I was saying. If I move over the 4, x to the 7th equals -4, take the 7th root. So x is the 7th root of -4. So what we're really doing by this process is trying to estimate the 7th root of -4. Okay. So here we go, same thing. X1 is -1. So the function is just the original. Now, if the original is not set equal to 0, remember you have to make it equal to 0. Here's an example. I'll show you shortly for number 16. 3 sine x equals x. So you have to subtract the x over 3 sine x minus x equals 0. Okay. All right, f prime is 7x to the 6th. So here we go. So use the formula. X2 is x1 minus f of x1 divided by f prime of x1. So my first guess they told me was -1 minus. Okay, plug in -1 to the function, put that on top, -1 to the 7th plus 4, right? Divided by 7 times -1 to the 6th. Derivative goes on the bottom. Right? Okay, x sub n plus 1. The new value is the old value minus function divided by derivative. All right, so -1 minus. So this is -1 plus 4 is 3. -1 to the 6 is 1. So -1 minus 3/7, -10/7. All right, do it again. So -10/7 goes in everywhere. -10/7 minus function divided by derivative. -10/7 to the 7th power plus 4 divided by 7 times -10/7 to the 6th power. Okay. This time I'll just say you can punch it out yourself. -1.5658. All right, so let me show you that. So I've done 6, 7, and 8. So I haven't done 70% of those. I've done 100% of them. Okay. So six, 7, 8. I've just done 6, 7, and 8. All right, so what's happening with the problems at the end? Now, in 6, 7, and 8, they gave us the guess. Number 6, x1 is -1. Number 7, x1 is 2. Number 8, x1 is -1. What if they don't give me a guess? Well, then you have to make up a guess. Use Newton's method to approximate the given number correct to 8 decimal places, and so on. Okay, so what happens after that? Okay, so up to now, everybody can do that with every calculator, even if you just have a standard calculator. Okay, so all of you can be able to do this. Now I will address those of you, which I think are most of you, that has a button with an answer key. Okay, so if you have an answer key, you are at quite an advantage in doing this. Even all these tedious calculations that I just finished doing, it becomes much, much nicer if you have an answer button. Okay, so what do I do now? All right, use Newton's method to approximate a given number correct to 8 decimal places. 8th root of 500. Okay, and I will start showing it to you, assuming you have the answer button. Now, if you do not have the answer button, it's okay. Just do what we just did before. You're a little bit handicapped because you're going to be a little bit slower in doing the calculations, but it's going to be much, much faster if you have that answer button, as I will show you. All right, so we're looking for the 8th root 500. First, we need to get a nice, easy equation. Raise both sides to the 8th power. 500 equals x to the 8th. X to the 8th minus 500 equals 0. Right? So you don't want to leave it like that. So raise both sides to the 8th power. Move over the 500, right? You have to have 0 on one side. So x to the 8th minus 500 equals 0. And yes, you will do the exact same thing for number 11, which is easier. And you have the answer in the back of the book. So 11 asks for a 4th root. So call that x, raise both sides to the 4th power, and then subtract the 75 over. If worst comes to worst, you have no idea what to do for 11. Look at what I do for 12, and 12 is harder. All right, so my function f of x is x to the 8th minus 500. Okay, so again, the original in black is 8th root of 500. Call it x. Raise both sides to the 8th power. 500 equals x to the 8th, and then subtract 500. So x to the 8th minus 500 equals 0. So my function is x to the 8th minus 500. Derivative is 8x to the 7th. All right, now, they do not give me a guess like they did for 6. Say, oh, start with -1. I mean, if they tell you what to do, then you got it. Number 7, start with 2. Number 8, start with -1. But 11, 12, 13, 14, 15, 16, they don't tell you how to start. Well, the 13 and 14, they kind of tell you. But nevertheless, what do I do? We'll start with some nice numbers. Okay. I'm looking for the 8th power of a number. Well, let's just start easy, like 1. What's 1 to the 8th power? 1, not even close, right? How about 2 to the 8th power? Okay. Some of you might actually know it. 2 times 2 times 2 times 2 times 2 times 2 times 2. 256. Okay, it's closer. 3 to the 8th power. Way past it, 65, 61. Right? Okay, I'm looking for a number to the 8th power giving me 500. 2 gave me 256. 3 gave me 65, 61. 2 is closer. So how about my first guess is 2? Sort of like an educated guess. Right? Now, I could do the same thing as all the previous problems. It would work. But now let me show you how very easy and convenient it is with the answer key. Okay, so if you don't have an answer button like this regular scientific calculator, then just keep doing what we were doing. Okay, but let me show how convenient it is if you have the answer button. Okay, a reminder that if you have an answer button, the last result that was done by the calculator is stored in its memory location called answer. Okay, so if I just do, I don't know, 5 times 7, 35. Inside the answer storage in memory is 35. So if I hit second function answer, see ANS, comes back with 35. So suppose I take 350 divided by 35, I know it's 10, right? But if I hit 350 divided by answer, to the calculator, it's the same thing as if I type 350 divided by 35. So I expect the answer to be 10. And there it is. Okay, and now 10 is located in the answer button, right? So the last calculation is stored in a special spot in the calculator called answer, ANS. All right, so here's the algorithm. Okay, X1 is 2. Type in 2. Okay, so you start with the first guess. So if you're following along with me, just type in the number 2. Of course, you see 2. So what answer is in memory now is 2. So if we hit second function answer, there's 2. Now, instead of actually typing the 2, everywhere in the formula, right? I'm not going to type in 2. I'm going to type answer. So I'm going to type it exactly like this. Answer minus function divided by derivative. Okay. So everywhere I'm supposed to put 2, I type answer. So let me show that to you now. And if you want to follow along, you may. And you should always put extra parentheses around the whole top and whole bottom. So I'm going to hit answer. I'm literally typing it like that, essentially. So answer minus parentheses, answer to the 8th power minus 500, close parentheses, divided by parentheses 8 times answer raised to the 7th power. Okay, 2.238 or whatever. Okay, and I'll show you exactly what I type. I type exactly what I have here. So I can show you both on the same screen. I'm not sure how well you can read that. Oops. Okay, so answer minus parentheses, answer to the 8th minus 500 divided by 8 answer to the 7th power, 2.238, blah, 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 blah. Okay, and if you're doing this for me, you should show me your approximations. Okay, so that's the procedure now. Again, if I'm going too fast, look at the video later. That's the advantage of having the videos. So you can go back and see this. But I typed in answer. Well, I literally typed this, answer minus answer to the 8th minus 500 divided by 8 answer to the 7th. Now, what is stored in the memory location of answer no longer is 2. It's now 2.238, blah, 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 blah. That's in memory. In addition, the calculator stores the last command, which was this. So as far as the calculator is concerned, this is the operation and this is the answer. So watch what happens. All I'm going to do now. So for you folks that don't have this button, sorry, you'd have to actually type it all in again. And you saw how I did that for problem 6, 7, 8. But for the answer key, all I have to do is press enter. I press enter. 2.18, what I have here. Press enter again, 2.174, and so on. It already has this stored, so I don't have to type it in all over again. Each time I press enter, it knows, oh, this was the operation. The last answer was 2.2 whatever. So as far as I'm concerned, when I type answer, it's just like to the calculator, 2.238, blah, 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 blah. Okay. And then iteratively, it does it again and again. It's very nice, very convenient, right? 2.187. Okay, and if I just press it again a couple more times. Okay, I keep going. And they say round to 8 decimal places, 2.174559228. 2.17455927604. Okay, see how these two are the same? Technically, they're not really the same, but they're the same to my accuracy is what? 10 digits or something like that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 digits to the right of decimal point. Then I'm pretty confident that's the result, because in my formula, that now means this fraction is 0, which means the top is 0, and that's what I was looking for. Okay, so one more time. Instead of typing it all in, I just typed it in once. Okay, so again, you have to type in your first guess, 2. Type all this in. That gives me my x2. But after that, I just kept hitting enter, 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 enter all the way through. Okay, so you see how nice it became. All right, I think I have time maybe just for one more of that type. Let me show you what I did for that one. Number 12. So that was 12. I'm going to jump over to 16. Use Newton's method to approximate the indicated root to 6 decimal places. The negative root of e to the x equals 4 minus x squared. And they tell me that it's negative. I'm sorry, 16. The positive root of 3 sine x equals x. Okay, yeah, I'm going to make sure I do an even one, hopefully. Okay, so 3 sine x equals x. This has to be in radian mode, so I better make sure. So yeah, I was last in degree mode because I was teaching trig, and we were in degrees at the time, so I got to make sure I'm in radians. So everybody make sure you're in radian mode for this one. Okay, I'm in radians. 3 sine x equals x, 6 digits. Okay, see how the right-hand side is not 0? I make it 0. Just subtract over 3 sine x minus x equals 0. So that's my function. Derivative is 3 cosine x minus 1. Okay, so how do you know what to pick? Well, I know I can't be any bigger than 3. I know sine is stuck between -1 and 1, right? So for instance, this can never be 4. It can be 3. Okay, but then, that's not likely going to be it. So I decided to pick 2. X1 is 2. I don't know that it's going to work. It probably isn't going to work. And they told me to pick a positive number. Okay. And by the way, it shouldn't matter if I pick 2 or 1 or 1.5, they should all work. All right. So again, key thing for this one, the right-hand side has to be 0. So if it isn't, force it by subtracting. All right, function derivative. Okay, so my first guess is 2. So I'm going to type 2. You must start off with the first guess of 2. Then after that, answer minus function over derivative. So answer minus 3 sine of answer minus answer in parentheses on top. Then 3 cosine answer minus 1 on the bottom. Okay. So here we go. So I typed in my first guess, which is 2. And now answer minus parentheses 3 sine. Again, those of you, when you hit sine or any other function, if it automatically gives you a left paren, you got to close it with a right paren. So I'm actually going to type it in like that for those of you that have that. So parentheses, answer, close parentheses, minus answer, close parentheses, divided by parentheses, 3 cosine parentheses, answer parentheses, minus 1 parentheses. Okay, so that's a lot there. Okay, so this is what you want. You need parentheses around the entire top and the entire bottom. So you can see, try to show you both on the same screen here. This is what I just typed there. Answer minus 3 sine answer minus answer, close parentheses, divided by 3 cosine parentheses answer minus 1. Okay, 2.32. You don't have to write all the digits until the very end. Just tell me what you see roughly. Okay, and yeah, now if you don't have a calculator that has an answer button, just do what we did for problem 6, 7, and 8. But now all I have to do is just keep pressing enter. 2.27 blah blah blah. 2.27886. 2.27883. And I get a match. In fact, right now you can see every digit is the same. So to 6 decimal places, 2.2788626 means I'm going to present it as 8863. All right, now I'm going to continue tomorrow. I'm pretty much done. I do want you to give me one thing in the chat, if you don't mind, if you would. Okay, it's not an in-class assignment. I just want to ask you, does your calculator have the answer key or not? So I just want a yes or no. I do, or I don't have an A and S button on my calculator, so I know whether it's going to be easier or harder for you on the test. Okay, so let me stop this. On your way out, just put either a yes or no, and I'll just go ahead and put that. So does your calculator, can't even spell calculator have an A and S button? Okay. All right, so just type that in your chat, either yes or no, and then I'll see you tomorrow. That'll be it. Okay. All right, bye everybody. Have a good day.